All right, today we're talking about exponent properties, and I want to talk to you about a few of them. We got to be able to handle problems like this. Basically, if they're set up like that, you add them. If you set up like this, you divide them. If they're set up like this, you multiply them. And if they're set up like this, it's just splitting it into two parts. That's nothing really revolutionary there. I want to do a few problems with you. Get to a blank page. I'm going to give you a problem. I'm going to see if you remember whether you add, subtract, multiply, or divide. The powers. So if you have a to the second times a to the fifth, is that the kind where you add or multiply? All right. Only one person confidently said add. Now, how can you know for sure? See, that's the thing. You're going to go home and I can't remember. Should I add these? Should I multiply these? Is it a to the 10th or is it a to the 7th? It's obviously one of those two. So here's how you should do it on all of these. As soon as you have it memorized, you can stop doing this. But until you have it memorized, you should go like this. AA times, what do you think I'm going to do? A. Do you get how that tells you what to do? From here, could this possibly mean a to the 10th? Would that make any sense at all? No. If you rewrite it like this, you'll be able to tell. That's got to be, look at how many a's there are, and they're all multiplied, right? It's just one giant multiply. So that's got to be a to the 7th. That makes a lot more sense. Let's do another one like that. Let's say I had a to the 2nd to the 5th. What does that mean? Well, that means a to the 5th. Now, without having to write it all the way out, that's good enough for me. Can you tell whether this is a to the 7th or a to the 10th by looking at it this way? It's a to the 10th. And if you weren't sure, what does to the 5th power mean? It means I make 5 of these. A, and A. Do you get how that's what that means? Now, how do you get its a to the 10th? If you break it down into what it means, it helps you understand it a lot better. All right, so how about if I say another one like this? Let's use variables. A to the 3rd to the 9th. What is that? A to the 27. All right. I want to do a bunch of rapid fire answers. I want you to shut your iPads. I want you to just answer chorally, as in sort of like you're a choir. You just say what you think the answer is. Okay? And it's okay if somebody says it first and you join in with them, that's all right. Just be careful you're not joining in on a wrong answer. All right? A to the 3rd, I'll keep it simple for now, times a to the 8th. A to the 11th. All right, good. A to the 3rd to the 8th. A to the 24th. Good. And if you want to just say the exponent, that would be a little faster and easier. All right, so what if we had a to the 5th to the 2nd plus, times a to the 3rd. Take a second, think. 13th. You guys were right. Because this part was what? And that part was, you put them together and you make, all right, good. How about this? A to the 3rd over a to the 2nd. What do you think the power is now? That's not a power. A to the 1st. Good. A to the 13 over a to the 2nd. Now what? A to the 11th. Because you subtract them like this. If you were on a problem like this and you get stuck, do you remember what I said to do? Break it up. What's a squared mean? A over a. And do you get how one of them cancels? The final answer, a to the 1. So when you get stuck on these, and you'll forget sometimes, break it down into its parts. It really, really helps. So if you see a to the 3rd times a to the 2nd, and you're like, oh, multiply or add them, you should go a times a. And then it'll be more obvious. What is it? A to the what? A to the 5th, not a to the 6th. Yes? Good question. What if the number on top is smaller than on the bottom, like this? Well, let's break it up into what it means. A to the 1 just means a, right? What's a to the squared mean? A. Can I cancel? Can I or not? Yes. And what does it leave behind when it gets canceled? A 1. So it's 1 over a. Is 1 over a right answer? Yes. If you wanted to rewrite that with a negative exponent, It would also be a to the what? -1. And that's the same thing I would have had if I took 1 minus 2. Get that? So either of those is a good answer. 1 over a or a to the -1. And it's important to understand what a -1 exponent means. So if I have 8 to the -1, what does that mean? -1, what did that do? It made it into a fraction. 1/8. What if I have 9 to the -1? What's that mean? 1/9. All right. What if I had a to the -3? What's that the same as? Nope. A to the -3. Nope, you're getting warmer. It's a fraction. 1 over a to the 3rd. See that? Okay, what if I had m to the -2nd? 1 over m squared. Good. All right. Going through just a lot of examples of ones. Okay, how about do fractions for a minute here, and then to the 0 power. That's an important one. When are we out of here again? Oh, what? At 13? Okay. So a to the 0 power. It's just a definition thing. It's a fact. It'll always be what? 1. It does not matter what the thing is. If you put it to the 0 power, it will equal 1. I will show you why, though. If I had a squared, let's do it with numbers. 2 squared. What's 2 squared? 4. What's 2 to the 1st power? 2. What's 2 to the 0 power? And do you get how that should logically work? Do you get why it should be 1? Let's just go down and go, half of 4 is 2. Half of 2 is 1. See? What if I had 3 to the 2nd? What's that? 9. What's 3 to the 1st? And what's 3 to the 0? And doesn't it make sense to you that it's logically stepping down 1/3 of what it was before? Okay. All right, so the 0 power actually makes sense. But it gets kind of crazy when you start saying 7.2 to the 0 power. What is it? Well, it's just always going to be 1. And you could do a progression on that too, and it would make sense if you made 7.2 to the 2nd, and then you figured out what 7.2 to the 1st was, that it should be 1 when it's done. All right. Next one is fractions. Say I had 2/3 to the 3rd power. Well, the key on this one is that both of them can be cubed separately. So this means 2 to the 3rd over 3 to the 3rd. It's almost like you're distributing that 3 to both parts. Get what I mean? So then what's 2 to the 3rd equal to? 8. And 3 to the 3rd? 27. Good. So what if I had 1/4 squared? 1 over 16. Why didn't you touch the top? It's just you did square it. It's just that it's 1 squared is still 1. Okay, good. How about if I had 3/4 squared? Oh, not squared, not to the 9th. That's awful. Squared. What's that? 9/16. Good. All right. Next concept that's a little tougher is fraction exponents. Okay, well, maybe we should do this first. A to the 0, B to the 5th, and C to the -2nd. If they're all like the same letter, it would be different. But these are all different letters, so they cannot go together. Like I can't put this and this together. But I can simplify some little things. Like what do you see up there that I can simplify? Yes? 1, because A to the 0 is 1. That's a 1. Does 1 go with the B? No, this is all a big multiply, and 1s and B's can't be put together, so I leave them separate. And how about C to the -2? How could you possibly rewrite that? Ah, yes. Over C squared, that's right. The way I like to think of this is that those are not happy up there. See how they're negative? If you're a negative person, you're not very happy. They're not happy up there. If I put them on the bottom, do you get how they'll be positive and they'll be happy? So you got to put them in the other place if they're not happy. So if I had 5a to the 3rd over b to the -2nd, are those b's happy down there? No. They want to be with everybody else, so let's put them up to the top, and then it would be b to the +2nd. They'll be positive now. They'll be happy now. See what I mean? Same thing happens if they're on the top and they're not happy. 5a to the -3rd over b to the 2nd. Those a's are not happy where they are. Let's make them happy. So where should I put them? On the bottom. Do I leave them as -3rd? No, that wouldn't be this. That wouldn't make any sense. I have to change it somehow because I'm changing it from the top to the bottom. So a has to be to the positive third now. So there's my final answer. You always want to write your answers without any negative exponents in them. Okay, so you should never leave an answer that has a negative exponent. Is it true that 1 over a to the third is equal to a to the negative 3? Yes. 1 over a to the third is a to the negative third. Those are both equal. But our preferred answers don't have negative powers in them. So we want this answer. It would be comparable to saying this. Is 4/8 the same as 1/2? Yeah, they're the same, but we have a preferred answer, right? Only one of those two is actually the one we want you to write down. We would want you to write down that one. That's our preferred answer. Same thing. These are both equal, but this is the preferred one because it doesn't have negative exponents. All right, I want you to try one. On your iPad again, I want you to get to a blank page and try that one. We've been practicing this since the beginning of the year. You know, do you remember that on the top 20 sheet? Exponents is one of the things that kids are awful at, so I had you practice it over and over and over again. Remember how numbers go with numbers, letters go with letters? You've done this literally 14 times because I gave you 14 versions of that practice. So you can do this. Now, the 27 and the 18, that's a bit of a pain. What goes into both of them? 9. So what you should be thinking of it is divide both of these by 9. 27 divided by 9 is 3. And 18 divided by 9 is 2. There we go, 3 over 2. And now my x's. Could I leave this as x to the negative 5 on the bottom? Kind of. But we really don't want to, or sorry, x to the 5 on the bottom. Yes. And that's good because it's positive. I'm sorry, I was thinking of the other way around. So it's best if you leave your answer like this with an x to the 5 on the bottom. The way I would think about that is not the 3 minus the 8, because then you'd be putting it up to the top and saying x to the negative 5th. Would this also be right? Well, kind of, but then you got to fix it by moving the x down. See what I mean? So it's smarter to just say, all right, a bunch of my x's are going to cancel. There's x, x, x on the top, and there's 8 of them on the bottom. And so I'm going to cancel off 3 of them, and I'm still going to have 5 on the bottom. So x to the 5th. And then how about my y's? How many y's are left, and where are they? 4 on the top. Y to the 4th. And then how many z's are left, and where are they? 3 on the bottom. Now, if you had come to a problem that had a negative left, like right there, is it okay to leave it like that? No, you got to make it happy, move it up to the top. So I'd take this and I'd put it up here and I'd call it x to the positive 5th. But we didn't have that in this problem. I'm just kind of preparing you for the future on that. All right, that would have been the right answer. Raise your hand if you had that one already before I did. Okay, awesome. There's lots of people waiting at the door. I'm guessing they're your friends that want to pick you up on the way out of here. So I'm going to let you go to lunch now. We go. All right, so we're back from lunch, and we were talking about these exponents. Notice how it says simplify without negative exponents, and that was important to know that we want our answers without negative exponents. It's not like they're illegal, but it's sort of a best practice. This is when you're done with your problems, they shouldn't have negative exponents. All right, let's look at the next one. Everybody go to this one, please. Get it up on your iPad so that you can try this one. Remember how I said you sort of distribute the 5? This needs to go here and there and there. But if you're going to do that, maybe you should clean it up on the inside first, because Evan and I also said that you always start difficult math problems on the inside. Remember that? So if you start on the inside here, inside the parentheses, maybe you could clean those up. There's some variables that are unhappy in there. Make them happy. Put it all together. They're all n's. Can't they all just get along? Be n to the something? Figure that out, and then put it to the 5th. All right, so these guys down here, they're not happy. So bring them up there. That makes that n to the 9th. N to the 9th times n to the negative 9th. Ooh, that's weird. n to the ninth times n to the negative ninth. Well, what do we normally do with those powers like that? Yes, you could say this is 1 over n to the ninth, just like this. See? And move it down there and make them happy. That'll work. And that'll come out to n to the, wait a minute, what happens to all of them? They all cancel. Is the answer 0? No. The answer is what? 1. Because this cancels this, and then they turn into 1s, and so it's 1 over 1, and that's 1 to the 5th, which is 1. Raise your hand if you had 1 for a final answer. All right, good job. Now, if I go backwards and say, couldn't you have done it a different way, Mr. Server, and just added these together? And then that would be n to the what? 0. And what's n to the 0? It's equal to 1. Still would have worked. All right, let's move on to the next one. Try that one. Remember the order of operations. Start on the inside. Really what that is that parentheses take priority. They're number one thing you do. This one, I'd like you to turn and show me what you think the answer is on your iPad. I'm going to pause for a second while you work these out. One thing a lot of people are going to forget is that the 2 on the bottom, that 2 has to get cubed also. A lot of people forget that. I wanted to not have to say that 400 times as I'm checking yours. Okay, since I had a lot of incorrect answers, I'm going to do a little bit and to see what happens from there. This is 2m to the negative 4th. Notice that negative 4th does not go on the 2 because there was no parentheses. In here, this case, we do a cubed on everything. So that would be 2 cubed, which is 8. And then m to the what? What? Negative 12th is correct. All right. From there, I'm going to pause for a second and see if you can do it from there. Okay, good point. I'm missing the m itself. The m is right here. M to the negative 12. All right, we're going to go a little bit further. These m's are not happy where they are, right? Can they go up here? Yes, they can. These m's are not happy where they are. So where do they go? Down. So then you have 2 over 8, and yes, eventually I need to fix that, but I haven't yet. And then the m to the 12th is on the top, and the m to the 4th is on the bottom. Okay, now take it from there. Let's see if we can all get the same answer. Okay, so that's on the inside. There's nothing really to do in there. So then I'm going to do this next. Everything needs to be put to the negative 3rd power. Well, 2 to the negative 3rd. Well, 2 to the 3rd would have been an 8. But to the negative 3rd, that's a 1/8. Like that. See that 2 to the negative 3rd turns into 1 over 8? And that's a b to the negative 3rd, which means they wouldn't be happy if I put it up here. But I put them down here, and they'd be totally happy. So b to the 3rd on the bottom. And then that a to the negative 12th, this is this, you multiply in that situation. So a to the negative 12th, if I put an a to the negative 12th, it's sort of right, but you want negative exponents out of there. So I should put a to the 12th down there to make it happy. And now I'm timesing all of that by b a to the 4th. Do you get how I could put it over 1? You can always do that with anything. That shows you that that ba to the 4th is actually on the top. Okay? So now I'm just going to move them right over here because times 1 doesn't really do anything, right? So ba to the 4th is on the top now. See? Now I can do some more simplifying. The b with these b's. One of the b's is going to cancel, so this is down to b to the 2nd. A to the 4th, a to the 12th. 4 a's are going to cancel. A. That's an 1/8 now. And then final answer, if everything cancels on top, it's really a 1 over 8b squared a to the 8th. Raise your hand if you had that one right. Oh, that's most of you. Good. Okay. So let's just see if there's any more. Yep, this is the last one we have to do. Try this one. Remember, start in here and try to make everybody happy. It's a bad idea in life because you can't make everybody happy. All right, so here's what I would have wanted here. The A's come up here to make them happy. These A's have to go down there to make them happy. So I'm going to rewrite a bunch of this so that everybody's happy. 4, A to the 4th, those are the ones coming from the bottom. On the bottom, those A to the 3rds that were on the top, they're going to the bottom. B to the 5th stays on the top. He was happy. And then the B to the negative 2, that comes up and joins them because they weren't happy down there. So now it's going to be B to the 7th on top. So this is what happens before anything else happens. Do you agree? Did I screw something up? Oh, there's a 4/5. Thank you. There's a 5 there. There we go. Good. Now I have to take that whole thing and put it to the negative 2nd power. I would do that in 2 stages. So don't think of that as a negative 2. I know it seems weird, but I would think of this as 2 separate things. Do you get that that negative just means that you're going to put 1 over everything? And I know you know what squaring means. You just square everything. So which is easier? I'd say squaring everything is probably easier. So let's square everything first. And then when we're all done, that putting 1 over something, did you know that that also means flipping it upside down? All right, so watch me. If I take this and I square everything, that's going to be a 16. The 4 squared is 16. A to the 4 squared is 8th. B to the 7 times the 2 makes 14 over, I probably should have simplified that a little more on the inside first with those A's, but I didn't, so it's okay. 5 squared is 25. The A to the 3rd squared is A to the 3 times 2 is 6th. And then that's it. Everything's been squared. And now what's left is I still haven't done the negative, and I guess I could call it a negative 1. And that means flip it all over. So then the stuff that's on the bottom comes up to the top. And the stuff that's on the top goes down to the bottom. 25a to the 6th over 16a to the 8th, b to the 14th. And I'm really close, but I still haven't dealt with these a's. I should have done it earlier, as I said. But now I'm going to say a to the 6th. That's like a, 6 a's. And then I'm going to cancel off 6 of these, and that leaves it with only 2 left. There's my final answer. 25 over 16a squared b to the 14th. Anybody have that same thing? All right, that was only like 5 of you, but I understand. That was a tricky one. Do you get how I took it in 2 parts? I squared everything first, and then that negative means you flip it. You might be thinking, well, when we had an 8 and you put it to a negative, you didn't flip it? Well, actually, I kind of did. Do you get how if you have an 8, it's really an 8 over 1, and then when you flip it, you get 1 over 8? So really what the negative is it's flipping it. So it's a fraction like this. You just have to flip the fraction over. Top becomes the bottom, bottom becomes the top. Any questions? All right, that was the hardest of all. So now you have a homework assignment, which is in Schoology. I think you know how the drill works. You got the homework there, the answers are there. Check yourself, make sure you're doing a good job. That's due the next time we meet. And this class won't meet tomorrow, but it will meet on Thursday. Okay? So on Thursday, also tonight, or tomorrow night, actually it doesn't really matter, by Wednesday night you have to have your iMovie done and submitted on Schoology. Okay? All right. If it doesn't come in on time, it will be late, and it's usually a 10% late penalty for something like that. So that hurts, knocks you down a whole grade. So don't do that. Okay, that's all I got for you.